on your relentless request and immense demand. Part 5, metals and non-metals, is before you, and now today we are going to discuss in length and breadth the chemical properties of non-metals. Non-metals are electronegative in nature, that is, they have a tendency to gain electrons. First, let's discuss the reaction of non-metals with oxygen. The non-metals with oxygen, when they combine, they form non-metallic oxides, which are acidic in nature, but there are few non-metallic oxides like nitrogen monoxide and carbon monoxide, which are neutral in nature. Let's start with the reactions. So first is reaction of non-metal. I will use the abbreviated form non-metal. I will use the abbreviated form non-metal with oxygen. So as I have told you, with oxygen non-metal forms non-metallic oxide. So non-metal plus oxygen gives you non-metallic oxide. Non-metallic oxide. Let's give some concrete example. Very simple. Carbon reacts with oxygen to give you carbon dioxide gas. Similarly, the sulfur non-metal combines with oxygen in the atmosphere and gives you sulfur dioxide gas. Now, if you remember correctly, in your lower classes, you learned about acid rain. SO2 is one component which produces sulfuric acid when it combines with the water molecules in the atmosphere and causes acid rain. Both of these, even CO2 forms carbonic acid there. So as I have told you, these oxides, these are oxides. This is carbon dioxide gas and this is sulfur dioxide gas. Now there is P4 plus 5O2. Phosphorus combines with oxygen to give you P2O5, 2P2O5, phosphorus pentoxide. Phosphorus oxide, we say. This is phosphorus. Actually, it's phosphorus pentoxide, or we can say phosphorus oxide. All of these are acidic in nature. That is, when you put a sample of these oxides dissolved in water into sample of litmus solution, then the litmus will change, the color of the litmus will change from blue to red, indicating they are all acidic in nature. Next we'll discuss these non-metal oxides. So reaction of non-metal oxides with water. Let's see what they form. For example, CO2, the non-metallic oxide, when combines with water, gives you carbonic acid. The confirmatory test to predict H2CO3 is a sample of this H2CO3, put it into a test tube containing blue litmus rather, and it will turn to red, indicating it's acidic in nature. This H2CO3 is a pretty weak acid in nature. Next, similarly, sulfur dioxide, when combines with water, it produces sulfurous acid. This is carbonic acid. Next is S2SO3. This is your sulfurous acid. Next is when sulfur trioxide combines with water. Remember, this is sulfur dioxide, and the next one is sulfur trioxide combines with water, gives you a very strong acid, very popular one, S2SO4 sulfuric acid. Phosphoric acid is also formed from phosphorus oxide when it combines with water. So we'll write here P2O5 plus 3H2O. It gives you S3PO4 and 2. 5 plus 3. Yes. This is phosphoric acid. Now let's see whether nonmetals react with acid. So now next is reaction of nonmetal with acid. Actually, interestingly, nonmetals do not react with acid. Why? Because they do not lose electrons. That's the main reason why nonmetals do not react with acid. So take any nonmetal, they will never say C plus S2SO4, for example, carbon element, no reaction at all. So we can generalize nonmetals with acid, no reaction at all, as they do not lose electron in acid. So there is no reaction at all. Now we have discussed in detail about reactivity series, how a highly placed metals displaces a lowly placed metal from its salt solution, because they are strongly reactive compared to the metals which are placed below. The same patterns follows also in the case of non-metals. Let's rub this area so that I can squeeze out some space for you. Now, so what's the thing? A strong, more reactive non-metal displaces a less reactive non-metal from its solution. Now, when chlorine combines with potassium bromide, is there any reaction? For that, we have to compare the two non-metals present here, one chlorine and bromine. We will not comparing overall the potassium bromide with chlorine. Remember, many people will do the mistakes in the exam. They will say that potassium bromide is less reactive than chlorine and chlorine is more reactive than potassium bromide. Wrong answer. Absolutely bizarre concept of chemistry. You have to compare, identify. Here it's very clear, chlorine is outside, bromine is along with the potassium bromide. So you have to identify bromine, the non-metal, from here, then compare their reactivities. chlorine is more reactive than bromine, and hence chlorine is able to displace bromine. It will easily displace bromine from potassium bromide, and then you will get what from its salt solution. Now it will become 2K potassium chloride. Potassium bromide will become potassium chloride, along with bromine gas is evolved. Now it's very important to remember the degree of chemical reactivity of some of the important elements, like chlorine is more reactive than bromine, and bromine in turn is more reactive than iodine. Why this is so? Because chlorine is more electronegative compared to the other bromine and iodine, and hence it is more reactive compared to your bromine. Hence chlorine is capable of displacing bromine from its salt solution, or even iodine from its salt solution. Bromine can displace iodine from its salt solution, but it cannot displace chlorine from its solution, because now if the question comes in the board, bromine plus 2KCl, will there be any reaction? Will there be any reaction? At times it comes. So here again the same thing. You know now that bromine is less reactive than chlorine, so it cannot displaces this one. So no reaction at all. No reaction at all. Keep on studying hard, and hard work has no substitute. So enjoy your good luck, and keep on liking, keep on subscribing, and keep on supporting. It's a noble cause, and here I'm here, and I promise you to deliver excellence in teaching, excellence in learning. Whatever things you are going to learn, I want you to have a solid mastery over it. So till then, bye bye, till we meet in the next episode. Bye bye and take care.